for the opportunity to present to you the revitalization of the Portland International Marine Terminal here in Portland, Maine. This is a project I have been working on since 2009 when I started at HNTB, and it has been a privilege and an exciting opportunity to watch the terminal grow and benefit from the engineering work of so many consultants in our engineering and construction community. This is the general outline of the presentation. I'll talk briefly about the Tiger Grant application, and then I'll dive into the technical aspects of the project. These items are listed by category, but you'll see that various aspects have been completed in multiple phases over time. For example, we have designed over 20,000 square feet of wharf infill areas and replaced 16 fender panels along the waterfront. There's now a 3,000 square foot office space and a new maintenance and operations building on Commercial Street. And there's now 152 new electrical outlets for refrigerated containers, along with all the utility upgrades. There's now over 1 mile of new railroad track and over 1 acre of a concrete loading slab for rail packing. And finally, a half-mile long internal heavy haul road for which we just completed the design and is scheduled for advertisement this spring. I'll discuss these improvements over 4 phases beginning in 2009 and going through 2021. You may recall the original Tiger Grant application process, which was deemed very competitive at the onset. We worked with the Maine DOT and the Maine Port Authority to develop an application for Maine's 3 primary ports, Portland, Searsport, and Eastport. We requested $32 million for 5 projects. One of the projects was the Portland International Marine Terminal. And at the time, the Maine DOT and the Maine Port Authority were considering not only increases in container throughput, but also the potential development of Maine's wind industry. As such, we looked at the competitive advantage of Maine's proximity to the location of wind turbine and blade components and the manufacturers. 2 areas of interest were Brazil and Spain. Interestingly, we noted that Maine was closer to both locations by about 10% compared to other major ports to the south of us in terms of mileage, which would prove to be a cost differentiator for shipping and drayage. Here you see the mileage comparison for Brazil. And here, similarly, is mileage comparison for Spain. And again, the lower mileage will result in lower cost. Ultimately, we learned that the selection process was indeed very competitive. Over 1,300 applications were submitted, and only 51 awards were made. As you might guess, our application was successful. The Maine DOT received $14 million for its 3 ports. $5 million of which would go to the first phase of improvements at the Portland IMT. Now, I'd be lying if I told you that everyone had the next 10 years of development figured out right at that moment. We did not. However, this is a graphic illustrating, in perfect hindsight, what we have done over the last 12 years. I'll elaborate on most of these areas in the following slides, but in quick summary, starting at the top right corner is the 13-acre terminal proper, where the whole project started. Then moving westward to the left of the Casco Bay Bridge, we expanded the terminal by 23 acres to include a chassis storage yard, concrete loading slab, and a railhead. Improvements to West Commercial Street were also designed. And we have also designed an interior heavy haul road. In phase 1, we started with the terminal proper and essentially gutted the place and started fresh. Existing offices and buildings were demolished. A 10,000 square foot wharf infill area was completed. A 3,000 square foot office building was erected. Over 4 acres of upland container storage grounds were strengthened, and security features were upgraded, including fencing, sliding gates, key card entries, lighting, and PTZ cameras. Photos shown here reflect the original starting point, clockwise from the top left. Include the upland container storage area. Next, the original terminal building for the Nova Scotia Prince Ferry, many of you may remember. The mobile trailer, otherwise known as the port office building. The wharf, the original Leap Air 320 crane, and the condensed container storage site in 2011 as construction began. The challenges we were faced with included developing an upland container storage layout that would realize immediate efficiencies and satisfy future growth, yet still work within the confines and constraints that would exist after the first phase was completed. Here you see the proposed container terminal layout that we finally constructed. Note the width of the travelways and location of high-mast light poles placed around the site. Travelways are 50 feet in width to accommodate fire trucks per city code. And fire hydrants were located adjacent to high-mast lights and are protected by site bollards. One of the things we had to take into consideration was the prevailing winds off the coast, hence the reason for the containers positioned as they are parallel with the river. The proposed north-south travelways were aligned with the location of existing wharf access ramps. You might think this layout is straightforward, but it was a challenge to satisfy the lighting requirements, the fire hydrant spacing, and still maintain open flow for operations, any type of operations, and as you'll see on the next slide. Remember how I said the state was considering the transport of wind components such as blades, turbines, and nacelles. Here you see the geometric challenges we faced as we looked at truck turning radii for wind blades that were 160 feet long and were scheduled to move out of the terminal and travel up Commercial Street. Photos shown here clockwise from the top left include concrete wharf infill area construction, upland storage area paving, concrete wharf with precast deck panels, and pile installation. Concerns of seawall settlement and block shifting were alleviated by augering the piles the first 10 feet and spudding as needed to locate underground boulders or obstructions. Photos shown here clockwise from the top left include offloading of those wind turbine components and those stems, as you see in white on the slab itself. The first completed phase of wharf infill, and the finished 3,000 square foot office building on Commercial Street. In phase 2, we were alerted to the prospect of a new shipping company that would potentially call on the Portland IMT, an Icelandic company called ACEC. They have specialized in the transport of refrigerated containers for over 100 years and originally had their headquarters in Virginia to coincide with the headquarters of the US Navy. Their needs were simple: refrigerator outlets around the terminal and improvements to cross-dock operations, whereby containers are unpacked and broken down into smaller shipments for regional and local deliveries. So we needed to revisit our terminal layout plan. Here you can see that we updated the terminal layout to accommodate 152 refrigerated containers shown in blue. 136 on the eastern right-hand side of the terminal that would be stacked too high, and another 16 located near the cross-dock operations, also stacked too high. Ideally, during storage, 64 containers would first be placed along the eastern perimeter of the terminal, where they would not pose an obstruction, and then the interior bays would be used for overflow conditions. Photos shown here clockwise from the top left include an 8-outlet pedestal assembly, then the eastern row of pedestal assemblies and light poles, a concrete pad and 3 new door bays to improve cross-dock operations, and an IMSCIP container in transit. We wanted to avoid using the pedestal outlets near the travelways to prevent obstructions in the middle of the yard. So we devised in-ground handholds, which proved to be a unique approach and would store the outlets when not in use. The Maine Port Authority purchased 6 mobile 12-outlet assemblies shown here with extension cords that could be used during these overflow situations. And those are the small boxes you see adjacent to the blue containers shown on the left-hand side. Phase 3 improvements took a new whole level of terminal expansion with property acquisitions to the west of the Casco Bay Bridge and over $16 million in construction improvements planned, including a chassis storage yard, a concrete loading slab, railroad corridor with tracks and sidings, a multitude of improvements along Commercial Street, and fender panel replacement along the wharf. Here you can see the various areas that were improved between 2014 and 2017. These improvements did the following: increased throughput volumes for the port, increased the reach of regional markets to include Midwest and Canada, increased operational efficiency for Rhymeskip, reduced shipping costs for local manufacturers, and to bolster the economies of forest products, seafood, and agriculture. Remember when I said we didn't really have an overarching plan for the terminal? Well, toward the end of 2013 and heading into 2014, the Maine DOT, Maine Port Authority, and HNTB had a roundtable discussion one afternoon, and we outlined the next 4 stages of the Portland IMT expansion for the next several years. The culmination of that effort is the spreadsheet you see here, whereby we describe the project items that needed to be completed, who the responsible party was, the construction and design cost, and even the funding sources. Most of the items in the spreadsheet now comprise this presentation. Yes, the print is small, but you get the idea. One of our senior rail experts, Ralph Mazzeo, would enjoy doing the expansion drawings while he was semi-retired from his kitchen table, as he would say. This sketch here, titled Alternative E, is the one that most closely resembles the one we ultimately designed and constructed. You can even see in the lower foreground of the sketch the first notion of a cold storage warehouse being shown. Phase 3 of the project brought many new challenges as listed here. While many of the technical components were rather straightforward, the number of entities and agencies with whom we would coordinate was astounding for this phase. We coordinated with abutters, neighborhoods, businesses, utilities, and the city of Portland, all of which expressed strong interest in the project. One of the most significant aspects of this phase wasn't even within the terminal itself, but rather it was the proposed changes to West Commercial Street and egress to the expanded portion of the terminal. Here is a graphic of a new signalized intersection at the corner of Beach Street. Note the 2 entities, Gray Bar and Nova Seafood, whose frontage would be altered during the realignment and improvements to the intersection. Here is the design drawing that ultimately was constructed. Note the list in the lower right corner of all the improvements that were made. New designated left turn signals and left turn lanes, wide shoulders, striping, bike lanes, ADA compliant crossings, and raised islands for traffic flow delineation. Our design team collaborated on so many fronts with the city of Portland. Here you can see the graphics that were developed to illustrate the appearance of the final product. Note the bike lanes, concrete safety barrier, palisades fence, and clearly marked travel lanes. I mentioned the concrete safety barrier in the previous slide, but it wasn't always called that. At first, we simply called it a wall, and we didn't give it much thought, but the neighborhood residents in the city envisioned an 8-foot-high concrete wall that would block river views and basically be a monstrosity. When we described the wall as a 4-foot-high barrier, the city still wanted it shorter. So to convey the importance of the barrier and its functionality, to deter trespassers and safely protect the general public from heavy equipment, we had to illustrate our point by comparison to nearby existing bridge barriers that normally resist an HS-20 truck for impact. By comparison, the rail packer, also known as a reach stacker, or by their brand names Kalmar or MyJack, is a massive vehicle with wheels 6 feet in diameter. Note the person in the photo on the right. You can also see the weights of such vehicles by comparison. A rail packer can be 2 to 3 times heavier than an HS-20 truck. Here, the imagery really conveys the design team's concerns and the need to protect the general public and the traffic on Commercial Street. We were able to maintain a 4-foot-high safety barrier, as it was later named, and place the palisade security fence atop the wall to maintain views of the river. Note you can see the tops of the tires given their 6-foot diameter on the MyJack. And here's a simple image with the truck adjacent to the safety barrier for comparison. The concrete safety barrier was an opportunity to place an artistic flair to an otherwise cold surface. And so our landscape architect did some research and determined that the imagery would be a repeating pattern of 5 images of the old railroad valve maps from the 1920s for this exact parcel of land. Styrofoam templates were created and brought on site for city approval. Also in this photo, and on a different note, you see a swath of concrete along the base of the barrier. These are porous concrete slabs that were installed in lieu of a traditional catch basin and closed storm water drainage system due to a very large and sensitive 115 kV electrical line just a few feet below the surface, which serves this entire region. The slabs allowed us to minimize deep excavations and keep clear of damaging this line. Here's an image of the concrete loading slab. The inset illustrates a few empty spline cars, essentially chassis frames built for railroad use. The slab is over 700 feet long and approximately 100 feet wide. I mentioned that the fender system was also replaced along the wharf. Note the old system of vertical steel members lined with UHMW panels in the left photo, and the new closed steel panels with UHMW wearing surfaces in the middle photo. The design team determined that the existing rubber buckling fenders would satisfy the breasting energy of the iron skip vessels, and therefore only the frontal panels would need to be replaced. Improvements to Commercial Street are shown here. Clockwise from the top left include the bike lanes, travel lanes, bike racks and pedestrian pathways with ADA tip downs and detection plates, and cobblestone travel areas that provide turning space for large trucks, but which also prevent the general public from mistaking the area as part of the roadway. For the bike lane demarcation, we applied green glass beads, 2 millimeters in size, to an epoxy-lined 4-foot wide lane, recessed 1/16 inch deep into the roadway. The glass beads are highly reflective for safety, and the recessed construction prevents plow blades from scraping the beads off the pavement. Finally, Phase 4 improvements included another 10,000 square feet of wharf infill area and removal of the maintenance building. I should add that the piles here were 16-inch diameter, half-inch wall with concrete fill, driven to bedrock about 120 feet in length. The piles were epoxy coated with a fusion bonded epoxy, and each received 60-pound anodes for cathodic protection. We were concerned about the existing seawall during pile driving for fear that settlement might compromise the stability of the wall, which was founded on timber cribs. In fact, it was the pile installation for the foundations of the adjacent Casco Bay Bridge in 1996 that is believed to have caused settlement of the original ferry terminal building that led to cracked walls and moisture problems and ultimately condemnation of that building. The original concrete wharf was constructed in several different stages dating back to 1988. And while most areas were designed to 1,000 pounds per square foot capacity, the access ramps in the finger pier were designed for only 450 pounds per square foot capacity in HS-20 trucks. Through our extensive structural analyses over the years, we have identified which areas need to be replaced in the future, and we have shared this information with the Port Authority for future planning purposes. Construction space was tight, and the operational space was even tighter, as you can see here during ship offloading. Both entities, the contractor and the terminal, were unhappy with the limited space, so we knew we had struck the right balance. Actually, we established a system whereby the construction crew could relocate the temporary fence, which outlined the contractor's work area, and then use more pier space when the vessels were not in port. Note the containers in motion and the green piles sticking up in the background before proof driving, just to the right of the new blue mobile harbor crane stem. Here's an image of the final wharf and the 2 new Leap Pier 420 mobile harbor cranes and the old crane in the background. Note the maintenance building has been removed and the wharf front is much more open and efficient. And here's the final layout of the wharf with the 2 cranes in operation, unloading an IME-skipped vessel. So what are the results of these improvements? The Maine Port Authority reports that container throughput has grown 21% year over year during the last 7 years, since 2013 and the arrival of IME-skip. Certainly, this is a great achievement for the Maine Port Authority, the Maine DOT, the City of Portland, and IME-skip for bringing new energy and opportunities to this area of the waterfront. And it's amazing what can be done with prudent investments and the right infrastructure in place. And what does the future hold? Well, the terminal recently completed construction of a new maintenance and operations building. And you just saw the newly acquired second Leap Air 420 mobile harbor crane. There are still some items yet to start and finish. Cold storage building, heavy haul road, additional wharf area infills, and improvements to cross-dock operations, and possibly the transport or double stack rail cars in the future. There are a lot of people, agencies, and organizations that have helped make all of this happen. The Maine DOT, the City of Portland, Maine Port Authority, Soli DG, and so forth. And you can see that list here. Many agencies involved. And many engineers, designers, inspectors, and contractors who have made the vision come to life and who have truly revitalized the industrial section of the Portland waterfront, and particularly the International Marine Terminal. I'll pause for just a moment so you can see many of the players involved over the last 12 years. And that concludes my presentation. I'd be happy to answer any questions.